Alright, good day. Today we're going to be looking at a worked example under motion in a straight line. The example is already written on the board for safety of time. And I'm just going to read through the example for more clarity for those maybe who couldn't really see it clearly. First and foremost, the example on the board says a car accelerates from rest until it attains a velocity of 50 meters per second after covering a distance of 500 meters. We have to find the acceleration and the time of travel. We have to find the acceleration and the time of travel. So a car accelerates from rest until it attains a velocity of 50 meters per second after covering a distance of 500 meters. Find the acceleration and the time of travel. So in our solution, the first thing we need to do is to bring out the data. First thing we need to do is to bring out the data. So the first data we have is that the car accelerates from rest. So that means the initial velocity is 0 meters per second. 0 meters per second. It attains a velocity of 50 meters per second. That means the final velocity at the end of the day was 50 meters per second. It covers a distance of 500 meters. So it covers a distance of 500 meters, a distance of 500 meters. So distance is 500 meters, and we are asked to find the acceleration and the time of travel. To find the acceleration, first we need an equation that eliminates time, an equation that does not contain time. And the equation that does not contain time is v squared equals to u squared plus 2as. If we were to make acceleration subject of the formula, acceleration will rather be v squared minus u squared all over 2s. Let's make our substitution. V happens to be 50 squared minus u happens to be 0 squared all over 2 times s, which happens to be 500. So we see that 50 squared is already 2,500 minus 0 all over 2 times 500 is 1,000. Everything simplifies to give 2.5 meters per second square. So that's the equation. To find time, we simply look for an equation that does not include acceleration, or we could use our previous answer to actually solve it. So we look for an equation that does not include acceleration. And the equation that does not include acceleration is this. S equals to v plus u all over 2 times t. Although it's not a law that it doesn't include acceleration, we could simply use v equals to u plus at to also solve, since we already have our a to be 2.5, and then we make the substitution. If we solve for time, this should give us 2s all over v plus u. That's going to be 2 times s, which is 500 all over 50 plus 0. It's evident that this is going to be 20 seconds. So the time taken is 20 seconds. That's all for this example. It's as simple as that. Just know the appropriate equations to use. Every time you're given an equation and then you're asked to find more than one thing, just look for an equation that has one of the unknowns missing, and then use that equation first to begin to solve, and then you can proceed. For this one now, we can still use v equals to u plus at, and we'll still get the same thing. Okay, assuming we used v equals to u plus at, it means that t will definitely be v minus u all over a, and that essentially is more or less like 50 minus 0 all over 2.5, and you still arrive at 20 seconds. If you were to try it out that way, you still arrive at 20 seconds if you were to try it out that way. Thank you for watching. See you in the next video. Please like and share your Facebook timeline and get your friends to actually know about this. Thank you.